Preparing for a Terraform interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is Terraform, and how does it differ from configuration management tools? Terraform is an infrastructure as code tool that declaratively provisions and manages cloud or on-premises resources. I describe the desired state in HCL, then Terraform compares it with its state and the real environment before proposing changes. Configuration management tools usually configure software inside existing machines, while Terraform creates networks, instances, databases, and permissions. Terraform can work alongside Ansible. Terraform builds infrastructure, and Ansible installs and configures applications. That separation keeps responsibilities clear. While answering, explain infrastructure as code, declarative configuration, resource provisioning, state management, idempotency, and the distinction between Terraform's provisioning role and tools such as Ansible's configuration management focus. Question 2. Explain Terraform's core workflow from configuration to infrastructure changes. My normal workflow is write configuration, run Terraform in it, validate syntax, create a plan, review it, and then apply that approved plan. Init downloads providers and modules and configures the backend. Plan calculates the difference between configuration, state, and remote infrastructure without changing resources. Apply executes the proposed actions and records the resulting state. In C, I generate a saved plan during review, require approval, and apply that exact artifact to reduce surprises. Make sure to cover writing HCL, initialization, provider installation, validation, planning, review, application, state updates, and the importance of approving plans through automation rather than applying unreviewed changes. Question 3. What is Terraform state, and why is it important? Terraform state is Terraform's record of which configuration objects correspond to real infrastructure resources, including identifiers and selected attributes. It lets Terraform calculate incremental changes instead of recreating everything. State may also contain sensitive values, so I secure it with encryption, restricted access, and a remote backend. I avoid editing it directly because corruption can cause destructive plans. If correction is necessary, I use commands such as statemv, or import carefully. In your answer, discuss state as Terraform's resource mapping, stored attributes, dependency information, refresh behavior, sensitive data exposure, state locking, and why manually editing state files is risky. Question 4. How would you configure and secure a remote Terraform backend? For a team, I use a remote backend such as an encrypted object storage bucket with a locking mechanism. I enable versioning for recovery, restrict access through least privilege IAM, and separate state by environment or service. Backend credentials should come from short-lived identity or C roles, never committed variables. Because the backend itself must exist before Terraform can use it, I bootstrap it separately. I also test lock behavior and document recovery procedures. Be sure to mention shared storage, encryption, locking, access control, versioning, recovery, backend bootstrapping, credentials, and why remote state is preferable to local files for team collaboration. Question 5. What are Terraform providers, and how do you manage provider versions? A provider is a plugin that translates Terraform resources and data sources into API operations for a platform such as AWS, Azure, Kubernetes, or GitHub. I declare required providers with source addresses and version constraints, then commit Terraform lock.hcl so C and developers use verified versions. I prefer bounded constraints, test upgrades in a lower environment, review changelogs, and update deliberately. This prevents an unexpected provider release from changing production behavior. Focus on provider plugins, resource and data source implementations, required providers, version constraints, lock files, upgrade strategy, compatibility testing, and avoiding unconstrained provider upgrades in production. Question 6. How does Terraform determine resource dependencies? Terraform builds a dependency graph from references between resources. For example, an instance referencing a subnet ID automatically waits for that subnet. I use depends on only when a dependency is real but not visible through an attribute, such as waiting for an external setup operation. Terraform then creates independent resources in parallel and destroys them in reverse order. I avoid broad depends on declarations because they serialize work, hide relationships, and make plans less flexible. Cover implicit dependencies from references, explicit depends on, dependency graphs, ordering versus readiness, data sources, module-level dependencies, and why unnecessary depends on can reduce parallelism and obscure design intent. Question 7. When would you use count versus for each in Terraform? I use count when resources are interchangeable and a simple numeric quantity is enough. I use for each when instances have meaningful keys, such as environments or service names. With count, removing an item from the middle can shift indexes and trigger replacements. With for each, Terraform tracks stable keys, so unrelated instances remain untouched. For example, I might create subnets with for each over a map. I choose based on identity, not merely collection size. In your answer, compare indexed and keyed instances, stable identity, collections, adding or removing elements, migration implications, duplicate handling, and why for each is usually safer for independently managed named resources. Question 8. What are Terraform modules, and how would you design reusable ones? A module packages related resources behind a reusable interface of variables and outputs. I design modules around a coherent capability, such as a network or database, rather than one resource per module. Inputs have descriptions, types, sensible defaults, and validation. Outputs expose only useful values. I version modules, document assumptions, and pass providers explicitly when needed. A good module reduces duplication while preserving important choices, instead of becoming an opaque abstraction nobody can safely change. Mention module boundaries, inputs, outputs, encapsulation, defaults, validation, naming, provider passing, versioning, documentation, composition, and avoiding overly generic modules that conceal important infrastructure decisions. Question 9. How do you handle secrets in Terraform? I retrieve secrets from a dedicated system such as Vault, AWS Secrets Manager, or Azure Key Vault, and pass them through short-lived C identity where possible. Marking a variable sensitive hides it from normal output, but the value can still exist in state. Therefore, I encrypt and tightly restrict backend access, avoid committing TFVARS files, and never print secrets in outputs or logs. For especially sensitive values, I consider runtime injection rather than Terraform management. Discuss sensitive variables, secret managers, backend encryption, state persistence, redaction limits, ephemeral credentials, avoiding hard-coded values and outputs, and the difference between hiding display and eliminating state exposure. Question 10. What is the difference between Terraform Plan and Terraform Apply? Terraform Plan calculates and displays proposed additions, changes, and destructions. It is primarily a review step. Terraform Apply executes those actions, either after interactive approval or from a previously saved plan. In C, I save the reviewed plan, require approval, and apply that exact file. However, plans can become stale if infrastructure or state changes afterward, so locking in a controlled workflow matter. I treat plan output as a decision aid, not an unconditional guarantee. Explain that plan previews actions without mutation, apply executes changes, saved plans improve review integrity, refresh may query infrastructure, approval workflows, exit codes, and why plan output is not a permanent guarantee. Question 11. How would you detect and handle infrastructure drift in Terraform? Drift occurs when infrastructure changes outside Terraform's configuration and workflow. A new plan refreshes state and can reveal differences, while scheduled plans can detect drift continuously. I first determine whether the change was unauthorized, intentional, or owned by another system. Then I either update configuration and reconcile, revert the external change, or formally import and manage it. I use ignore changes only for documented ownership boundaries, never as a blanket way to hide drift. Be sure to cover refresh behavior, plan detection, out-of-band changes, ownership boundaries, import, ignore changes, reconciliation, policy, alerting, and the danger of blindly overriding manually made production changes. Question 12. How do you import existing infrastructure into Terraform? I begin by writing configuration that accurately represents the resource and its required arguments. Then I import the remote object using its provider-specific identifier, or use an import block for a reviewable workflow. After importing, I run plan and add or correct missing arguments until the plan becomes stable. Import only populates state. It does not create configuration automatically or guarantee ownership. I also document dependencies and verify that future changes are safe. Discuss writing matching configuration, identifying provider-specific IDs, Terraform import or import blocks, state verification, generated configuration limitations, dependencies, drift review, and avoiding imports without a long-term ownership plan. Question 13. What are lifecycle meta-arguments, and when would you use them? Lifecycle meta-arguments control how Terraform handles resource changes. Create before destroy is useful when replacement must preserve availability, provided names and quotas allow temporary coexistence. Prevent destroy protects critical databases but can block legitimate changes, so it needs an operational escape process. Ignore changes as appropriate when another system owns selected attributes. Replace trigger ed by forces replacement when a related object changes. I use these settings narrowly because they can conceal drift or create unexpected capacity requirements. Cover create before destroy, prevent destroy, ignore changes, replace trigger ed by, dependency implications, availability goals, safety controls, and why lifecycle settings should be narrowly scoped and reviewed for unintended replacements. Question 14. How do Terraform workspaces differ from separate state files or directories? Terraform workspaces let one configuration use separate state instances, which is convenient for lightweight variations such as development copies. They do not fully separate credentials, code paths, access policies, or operational risk. For production, I often prefer separate directories or root modules with distinct backends and pipelines, giving clearer review and stronger isolation. Workspaces can still work well when environments share identical structure and the team understands the resulting state and permission boundaries. Compare workspace isolation, shared configuration, environment separation, backend layout, access controls, blast radius, naming, and why workspaces are not always sufficient for strongly isolated production environments. Question 15. How would you structure Terraform across development, staging, and production? I put reusable implementation in versioned modules and keep small root modules for each environment or service. Each root has its own backend state, variables, permissions, and pipeline, reducing blast radius. Development can apply automatically, while staging and production require plan review and approval. I promote tested module versions rather than copying configuration. Environment differences remain explicit through typed variables and controlled overlays, not hidden conditionals that make production behavior difficult to predict. Mention reusable modules, separate root modules or directories, isolated state, environment-specific variables, promotion, C approvals, provider versions, policy checks, and minimizing copy-paste while preserving explicit environment differences. Question 16. What is Terraform state locking, and what do you do when a lock is stuck? State locking prevents two Terraform operations from writing the same state concurrently, which could corrupt resource mappings. If a lock remains, I first verify whether another job is genuinely running and inspect its owner, timestamp, and execution logs. I stop or let the active process finish when possible. Only after confirming it is stale do I use force unlock with the exact lock identifier and team awareness. I then run a fresh plan to validate consistency. Explain concurrent write prevention, backend support, lock ownership, waiting behavior, safe diagnosis, force unlock risks, failed process cleanup, and incident communication before altering shared state. Question 17. Why are provisioners generally discouraged in Terraform? Provisioners execute scripts during create or destroy, which introduces imperative behavior Terraform cannot fully model or reliably retry. They may depend on network access, credentials, timing, and an SSH endpoint, creating fragile deployments. I prefer provider resources, cloud init, image baking, or configuration management tools. A local exec or remote exec provisioner may be justified for a narrow external integration, but I make it idempotent, observable, and isolated. Provisioners should be an exception, not the default. Discuss non-declarative behavior, unreliable retries, connectivity requirements, hidden side effects, destroy time complexity, ID impotency issues, cloud init, configuration management, and rare justified use cases. Question 18. How do you test and validate Terraform code in a delivery pipeline? My pipeline runs Terraform FMT check, init, validate, linting, and security scans before generating a plan. I test modules with representative inputs and use policy as code to block public storage, excessive permissions, or unapproved regions. Integration tests can apply disposable infrastructure and destroy it afterward. The plan becomes a review artifact, with approvals for sensitive environments. I pin tool and provider versions, and I test upgrades separately rather than mixing them with application changes. Cover formatting, validation, linting, security scanning, unit or module tests, plan generation, policy as code, integration tests, approval gates, version pinning, and testing destructive changes safely. Question 19. How would you safely manage a Terraform resource rename or refactor? A Terraform address change can look like a destroy followed by a create even when the real resource should remain. I use a moved block to tell Terraform that an old address maps to a new one, or state MV for carefully controlled legacy cases. Then I inspect the plan and confirm no replacement is proposed. I apply the refactor separately from functional changes, back up state through the backend, and validate dependent references afterward. Mention address changes, moved blocks, Terraform state MV, avoiding destroy and recreate, plan inspection, backups, dependency effects, version compatibility, and validating identity before applying refactoring changes. Question 20. How would you design a safe Terraform workflow for a production team? I would store Terraform in version control, use remote encrypted state with locking, and authenticate C through short-lived roles. Pull requests run formatting, validation, security checks, policy checks, and a plan posted for review. An approval gate applies the saved plan to production, with separate permissions for planning and applying. I schedule drift detection, version modules deliberately, and maintain recovery procedures. Rollback means applying a known good configuration, not blindly reverting state. In your answer, include version control, remote locked state, short-lived credentials, pull request plans, policy checks, approvals, saved plans, drift detection, module ownership, rollback strategy, and emergency change procedures. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.